grammar symbols. The grammar symbol and the productions are represent the programming constructs. One such example today I'm going to construct. I'm going to consider is so the observe that it is the grammar says about the grammar says about how to declare the statements, how to declare the variables, how to declare the variables in particular language. To declare the variables, thus it as for this there is as for this grammar, the grammar. Now here is the here is so the T is a declarative statement. The T indicates that it's a declarative statement, and so T represent a type of the variables. A type of the variable. A type means it says about what is the type of the values, the type of the value associated with the variables. And the L represent it is the identifier or a list of identifiers, or just we can say it's a variables. So now we can see, now if you have got the only L has got one values, then is L is ID, or if the L has a list of identifiers, then it is L is so L comma ID, L comma ID. And T present it is int or float, a data type of a variable, data of the variables. So for this given question, this input string, the input string is given that for a given input string, the float ID1, ID2, and ID3. So this is the statement in the program. So for this statement, we need to construct. So annotate tree. First, you need to construct a parse tree. Using the parse tree, we can construct annotate tree. In the meantime, we need to construct the syntax directed definitions for the production of the grammar. So the similar example I have discussed in the previous class. So once again, I've taken this example. There's in the another form of the example I've taken here to make you understand in much better. So the first we start with the like here, in order to derive this input string, you construct the parse tree. Construct the parse tree in such that you start the construct the parse tree with the constructing the parse tree with the start symbol, Okay, now start symbol. So the start symbol here is the D is a start symbol. So therefore the D is a start symbol. Then the D derives so TL. T derives the TL. Now if you got only the statement like it is the float, then the float like the statement is just like it just a float and in. So then this parse tree is enough. So this parse tree is enough because so now the T is derived, that is replaced by the I, that is the T is replaced by the float. So then the L is replaced by the ID. So ID means it is A. This is enough. But for a given question has a list of identifiers, So therefore, this L is replaced by the L comma ID. So again, so this L is replaced by L comma ID. To get the derived to get the decide the statement, the input statement. So therefore, this is the correct the parse tree, and this parse tree is converted into the annotated tree. So Now the importance here is you look at the inherited attributes. As you know, the inherited attribute is derives the values from the siblings. The inherited attribute. So this is the inherited. See here, we know that. So there is the variables are the A, B, C are the variables. So A, B, C are the variables. But so we don't know what is A, what is B, and what is C. We don't know means we do not know what is the data type of the A, B, C variables. To know what is the data type, so you should use this the attribute float, that is type as a attribute, and the value for this attribute is float. So that is obtained using this node. This is the using this node. Then now, so this float value of an attribute type is derived. It is derived to, that is, so now this left right hand side the right side of a node D derives the value float to this, and so that value is passed to children nodes. So why it has to pass to children nodes? Because to say the value or to say the variable which data type of the variable it is. To say the data type of the variables, it has to that is the children nodes derives the value from its parent. So here is a children node derives a value from that's attribute value from the parent node. Again, in the same way, the children node derives the value from its parent node. The parent node. So that's why you can see the number is 1, the floating point value, then it is derived to its sibling nodes. From the sibling, it is the value is derived to its children node. So then again the children nodes will going to derive the value from the parent. So now we know that it is identifier, the identifier is E. So that identifier as the identifier this identifier is of type the float. So how the float is obtained? So this is the float is the data type of the float is obtained with the steps 1, 2, 3. So now we can say that. So with that we can say that. So it is the A is of type float. A is of type float. So now again when you move on, that is when you move on to this then. So one here is there is identifier. It's a B. Is identifier B. So now with this, with respect to this label of a tree, then we can say that B is also variable is of type the float. Then so when you move on towards the root of the tree, move up towards the root of the tree, then so this it is a variable called as A, sorry, A and the variable called as a C. Then so this C variable is again is of type the C. The C is of type the float. So by doing this, we can say that so this all the variables that is A, B, C are the variables of type the float. Okay. So this is the what I ask you to do as an exercise. I hope that you have done this. If not done, just correct your solution. Check out your solution and whether the solution is correct. If it is correct, well and good. If not, we can change to the given solution in the slides. So now next, let us take the next the examples. The next examples are somewhat interesting, and let us see how this examples can be solved using the concept, the attributes, the concept that is inherited attributes and synthesis attributes. So let us continue discussion with the next example. Yeah. So one thing I have not told about here is so how to write the syntax directed definitions of the semantics rules for each attributes. So now in order to write in order to write the syntax directed definitions or the semantics rules for each production. So in order to begin that, we can say you can start with this first. First, you can start with the production number 2. So production number 2 say that the T derives int R, where the int or float are the terminal symbols. Terminal symbols. So therefore, whenever there is a terminal symbols, the lexical analyzer will supply the value for this lexical value for the terminal symbols. So therefore, the semantics rules for this, you can write as, so T type. So because you are interested to know what is the type of the variables, correct? The data type of the variable, that is 4. So T is a type, T dot type equal to, it is integer provided by lexical. So therefore it is called as lex value. Okay, this is the one. And if it is the float, then it is written as, so T dot type, the T dot type, so is equal to, this is equal to, then it is that it is float, it's a float, then the float dot, then it is lex value, it is a lex value. Okay, so this is the semantics rules for the second production. So hope that you followed this. It's simple, as simple. So just you to say what is a type. The T dot type is equal to the int. How the int is obtained? Int is obtained from lexical. Okay, with this knowledge, with this understanding, so let us move on to the next concept, where we're going to write the semantics rules for the next production. So please look at this. Here is next we can say, look at this. So the next one, see next, if you take the next one, next production, you can take any production. So if you take the first production, next, here is the T. So what is T? The T is a type. T is a type. So what is L? L is a identifier. So T dot, so it is type. So type then is equal to T dot type, and so it is then followed by this L. So what is N? What is N means? It is a identifier or list of identifier. So let us say if the L is just identifier, then is written as, so the L dot type, L dot. So wait, before that, so what we can say is here, so this, we don't know what is the you know that this L derives ID, but we do not know what is the ID type. So therefore you have to inherit the type value from the siblings. You have to inherit the value from the sibling node. So why it is from the sibling? Because the sibling node, this is the here is a sibling node. The sibling node will contains the information, the type of the information, and the type is the float information. So therefore it has to be inherited. So therefore now to write the semantics rules for this production, so first you need to inherit. First you need to inherit the type, the type value of the type. So then we have to assign that. So that is done using this statement. That's okay. Yeah, here you can see. So here is the N. Here is the T dot type. The T dot type is a type of the variable. The type of the variables means it is can be integer or float. So that value is inherited and assigned to L dot inherit. L dot inherit. So L dot inherit indicates that it has derived or it has obtained a type attribute from the siblings. So once you obtain the that is the attribute value from siblings, then we can assign to in this way. The attribute that is attribute as inherited is assigned to its children node. That we can see here is here. So once you obtain the attribute is type. So that is obtained from the siblings, So it is assigned to this node. Then the inherited attribute is passed to children nodes, or the parent children nodes will inherit the property, they inherit the attribute from its parent. So that is shown in the statement. This is the statement. So here, so this is the parent node and its L1 is a child node. So the L is a parent, L1 is the child node. So the parent value, the parent attribute value is inherited by its children nodes. Inherited by the children nodes. So these are the semantics rules for the different productions. So first is the D derives DL. For that, this is the semantics rules. The second one is, like we can say, the second one is T derives int, and next one is L derives ID. L derives ID. This is the semantic. For this semantic rules, this is the semantic rules. So when you completely write all the semantics rules for the given production, a set of semantics rules that is associated with the production is referred as syntax definition, the syntax directed definition. So the complete solution, there is complete set of productions, and the semantics rules for each production is shown here. As I told, first you have to get the values, the float and integer. So once you get the type of the type attribute values, you can inherit to its sibling node. So after sibling node is inheriting, the children nodes will inherit from its parent. The children nodes inherit from a parent. Here is the N is a parent, the L1 is the child. So therefore, the L1 is a child node is inheriting from its parent. So this statement says that here is the ID, the value of ID is provided by lexicanalyzer, and that value is entered into the symbol table, and that we can see using ID then entry, ID dot entry. So ID dot entry indicates that the symbol is provided by lexicanalyzer, and that symbol is placed in a symbol table. So now if you want to know what is the variable, say for example A and its type, so look at the table, in the table entry, that's ID dot entry. So if the symbol is A, then the A dot A comma L dot INH. The A comma L comma A comma L dot INH says that its type is the A type is it is the integer or float. Okay, so this is the complete solution, the semantics rules, and the annotated tree. The annotated tree is shown in this diagram, and the past. So with this, we can say that we have completed the solution for this given question. Okay, that's one thing. So there is one more. The graph that is called as a dependency graph. The dependency graph is always drawn in the form like using the dotted lines. Then what is the need of this dependency graph? The dependency graph represents the flow of information from one node to the another node in the parse tree. The dependency graph indicates that how data is evaluated, the flow of information in the parse tree. The flow of information means, so now in this example, let us say here is the value of E, the parent, that is here is a node or node is labeled with the E. The value of this node, this parent node, is evaluated using the value of its children nodes, and that is shown here in the form of dependency graph. The dependency graph always presented in the form of the dependency graph is present in the and like using the dotted lines. Dotted lines. See, dotted line says that so the E value and T values are used to identify the value for this E. Okay, so that is the another way to represent the flow of information in the positive. So that we can see here that the same example. So the dependency graph for the example which you consider in the earlier class. So dependency graph. So dependency graph and the flow we can see there is N1 and N2. So these are the nodes evaluated first. Then N3, that is value of N1 is assigned to N3, that is value of digit is assigned to F dot value. So then at the same time, the value of N2 is assigned to the F dot value, that is the order is 4. So then you can see that it is the value of in F dot value is inherited and assigned to this T dash dot T dash symbols. So then from there, its certain nodes will access the attributes values. So therefore, it's indicated as a N6. And you can see this is the label, the dependency graph labels. Okay. So then your since this T dash contains epsilon, so therefore convert the inherited attribute into synthesized attribute. So then once you convert the synthesized attribute, so reassign that is reassign means so that is the parent node will derive its value from its filter nodes. So this filter node value is in the synthesized attribute is passed to its parent. So again this becomes a child node for this parent node. So therefore this child nodes pass the information, the synthesized information into this T. So finally we get as so 3 into 5. So 3 into 5 is an example. If you consider, then it is we get as 3 into 5 is 15. So now we can see this is the dotted lines. Dotted lines represent the dependency graph. That is so N1. It is the F depends on the N. The F is depends on a digit. Then here is so the N4 that is F. It depends on a digit. Then we can see next is here the N5 depends on N3. And similarly, the N6 depends on the N5. And similarly, then the N7 values depends on the N6, and N8 depends values on N5, and N9 depends on value on this N8. So the dependencies say that how this information is flow from one node to another node, and which node depends on which other node to derive its values. Okay, so with this, now we'll move on to the next question. The next question is, yes, this question is same as the previous example. It is int a comma b comma c. Okay, so for this, the question is ask you to write the std to process the simple variable declaration in the C program and write the dependency graph for the input. Okay, so this is the graph. See, dotted lines it is. Dotted lines. It's not. It is a dotted lines. All these are the dotted lines. So if you're not clear, then we can say I'll explain to. We can see this is the dotted lines. So these are the dotted lines here. These are the dotted lines. So these are the dotted lines. Dotted lines. If it's not still, it's not visible to you. Then what I can do is, so I can redraw it once again with the dotted lines. So you can say you should draw in this way. So it is, and this should be drawn in this way, like dot dot dot. So then it is dot dot dot. Then it is. So you should draw the dotted lines in the order. The first, then second, then next is the third, then here is a third, then next is so next is here you can see here's the next one, the fourth, then fifth, So in this way, based on the order, we can able to draw the dependency graph. Okay, next. So the next concept is about the construction of the syntax tree. The syntax tree are used for multiple purposes. The syntax tree The syntax trees are used for multiple purposes. The one purpose to represent it is the language constructs of a language. The language construct of a language. What are the language constructs means? Now, the example language construct means example is, let us say the example. Here is the language constructs means say I is equal to, so I equal to I plus 1, I plus 1. So then I'll say the while statement, the while. So this A of I, the A of I is less than V. So V is a some the variables are the some constant values. So now here is the program the constructs, the program language construct. The program language constructs, in other words, we can say it is the program, the control statements or the other statements of the program language. To represent that such the program language construct, these syntax tree are used. The syntax trees are used. So the syntax tree is also helpful. The syntax tree is also helpful to represent the language construct in the intermediate format, the intermediate form. So let us see what is yeah. So I'm using the new word called as the intermediate, intermediate representations. See here is the syntax tree gives the intermediate representation of language constructs. The syntax directed definitions gives the additional information for each productions by assigning the attributes and assigning the semantics rules. So the next is now. So the how to use this the syntax directed definitions and represent the language constructs in an intermediate format. Now the debate is why this intermediate representation is required. Why the intermediate presentation is required and why it should be there, why the different types of the intermediate representations should be there. So listen carefully here. The process, the processing stages of a language. The processing stages of the language means the different phase of the compiler. The different phase of the compilers means, as you know, first start with the lexiconizer, then next is the syntax analyzer, then it is next is the semantics analyzer. So then it is the intermediate code generator, so then it is the code generator, then followed by the code optimizer. So these are the different phases, as we are aware. Now, so if there is a language, let us say there is a programming language, I is a program language. The I is the program language. The I is the program language. Okay, I is a program language. So now let us say there's the machine, there's a machine, the Z. The machine with an E as the Z. Machine as a Z. And in the same way, there is a machine with the machine is the K. Now please observe that. Here is the language. There is a program language I, and there are two different machines, the Z and K. So there is one possibility is that we can generate or construct a compiler such that the compiler is exclusively for the program language I and for the machine J. So that is the construct the compiler, the construct the compiler for the construct the compiler for so this program language and for this program the machines. The another one is again see construct the program language for the program that is a compiler construct the compiler for the program language I and for the program the machine C. So then again in the same way, so construct the program that is compiler for the uh, program language I, then the machine C, or say machine M. So by doing this one, what happens is as the machines, the architecture different. As a machine architecture is different, we have to construct a compiler for each machines for the same language if the machines are different. The machines are different means example is now I am using this the IBM machines. Now I am using the IBM machines, and so let us say you are using the AMD processor, Intel processor or AMD processor. So now you're using the common language is C language. You're using the common language is say the C language. Now a compiler designer has to design a compiler for the C language and for the IBM machines. So then next in the same way, the compiler designer has to design a compiler for the C language, but machine is AMD machines, the AMD processor. AMD processor. And similarly, now the compiler design has to design a compiler for the C language, for the machine is the Intel processor. So by doing this one, we can by doing this approach, what is the disadvantage? It means it is the complexity of developing the compiler is increases because you can see the language is same, but the machines are different. Machines, the first machine is IBM, the second machine is the Intel, the third machine is the AMD. Okay, as the machine architecture changes, the compiler has to be changed. The compiler has to be changed for the same language, So this is the lot of so this approach has a lot of the disadvantages. To overcome this disadvantage, so we can use the another approach. So what is another approach means? We can split. We can split. What we can split is we can split the processing stages of the compiler as the front end and back end. Front end and the back end. See, front end means don't say that front end means it does the front end job. Back end means back end job. No, that's not correct. See, the front end means the front end of the compiler means which performs the operations of lexical analyzer, the syntax analyzer, and semantic analyzer. So then intermediate code representations. So now this three phases. So this three phases, that is the lexical analyzer, syntax analyzer, the semantic analyzer, and then intermediate code representations. Okay, so this constitutes the front end of the compiler. So the front end of the compiler means now. So this four the phases, the stages of the compiler, that is lexical analyzer, the syntax analyzer, the semantics analyzer, and the intermediate code representations. Okay, that constitute the first phase. That's first constitute the front end of the compiler. Okay, so now I'll continue this discussion. The meeting going to end in within a minute. So I request all of you to log in with the same ID and password. So we'll continue a discussion once we log in. That is we means you and me logins once again with the same ID and password. We'll continue a discussion So what I just now I saying about what is front end, then I'll say about what is a back end. So what is advantage of this approach? What is the advantage of this approach using the back end and the front end? So that let's discuss